Hi everyone, welcome to the part 5 of network devices. Previous to this, we have learned net transmission media and switching techniques. In transmission media, we have learned that transmission media is a media through which information flows between the one computer to another computer, right? And today we are going to discuss what are networking devices or through which devices our information is passed from one computer to another computer. So without much delay, let us understand what are network devices. So on this screen, you can see the definition for network devices. Now let us go through the definition. Network devices are components used to connect computers or other electronic devices together so that they can share file or resources like printer or fax machines. Devices used to set up a local area network are most common type of network devices used by the public. For example, for LANs, we use hub or a switch or sometimes router. For example, nowadays you can see in a lab there is a box which has 8, 16 or 32 ports depending upon the size of the network, and this box may be switch or maybe LAN where we can distribute connection to multiple networks or computers, workstation you can say that, right? Now, networking devices are also called communicating devices that we already know. Okay, so this is it. Now we should move to the next slide. Now here are some of the most commonly used network devices. Network interface card, we have learned this earlier also. This is also called tap terminal access point. Then we have a repeater. Repeater is used to amplify signals because over a due period of a time through the transmission media, signals are means diluted somewhat. So to strengthen these signals again, we use repeaters. Then we have a modem, which converts digital signals into analog signals and analog signals into digital signals. Now we have a bridge, hub, switch, and routers. We are going to discuss these devices in our later coming sessions, or very soon. You can say that. Okay, so let's move to our next slide. That is, you can see on the screen connecting devices. We have networking devices, interconnecting devices. We have routers and gateways. Now, bridges are used to connect two similar type of networks, and repeaters are simply used to modify the signals. So they are considered in our networking devices. An interconnecting network, basically we use to give connection to different type of LANs with the help of our routers and gateways. Okay. Now, coming to the first network device, which is very essential because without this we cannot connect a computer to a network. Actually, this has a port called LAN port where your RJ45 connector is inserted and through which we can connect to the network. Okay, let's go ahead and learn about this. NIC provides the physical interface between computer and cabling, okay, through which you can say that the transmission media and your computer device is connected. It prepares data, sends data, and controls the flow of data. It can also receive and translate data into bytes from the CPU to understand. It has a specific MAC address. In previous videos, we have learned about MAC address. So basically, MAC address is a physical address and which is uniquely identifies this network interface card. Actually, by understanding the 48-bit NIC, we can easily identify from which vendor or which is your manufacturer of the network interface card, and secondly we also can identify when it is made, so it contains all the information about a particular device. Now coming to the repeaters. Network repeater regenerate incoming electrical wireless or optical signals. With physical media like Ethernet is a cable we are talking about, or Wi-Fi, data transmission can only span a limited distance before the quality of the signals degrades. So basically, distance over a certain distance, your signals which we have transmitted will dilute or get weakened due to interference or due to resistance. Many environmental factors are there, so it is degraded. To, you can say that, regenerate these signals or amplify these signals, we use repeaters. Repeaters attempt to preserve signal integrity and extend the distance over which data can safely travel. For example, for a twisted pair cable, we have to use these type of repeater in 100 meters, yeah, or before 100 meters. Now, it can't filter the signal traffic. It work in a physical layer of OSI model, right? Now, you don't have to worry about this OSI model because it is not included in your CBSE syllabus. Now, the second is a modem. Actually, in the lower classes, you have learned about the modem. Modem is simply modulator and demodulator, which converts a digital information into an analog signals. That is called a modulation, and analog signals back to useful digital information. That is called demodulation. So, for example, if your information is traveling to the wire, so it is in a log form, and when it is inside the computer, then it is in a digital form. So, to convert these signals, we use modems. An ISP or internet service provider is required to complete a connection to the internet. Okay, this is the additional information. Digital subscriber line, asymmetric digital subscriber line. So this is the full form of ADSL and ADSL. Now, hubs. Basically, when we have multiple computers and we need to interconnect them, then we need a device which gives you multiple connection, and this device is called a hub. And hub is of generally two types, that is called active hub and passive hub. The difference between these two is active hub can modify signals or can amplify the signals, and passive hub is simply transmits the signal. It doesn't amplify the signal, that's why it is called a passive hub. And it has a limited utility because it is not that intelligent, because whenever it receives the signal and it is to be intended to a legitimate user, then it does not recognize each and every computer. It simply broadcast the information to all the channels, or everybody can receive this information, and only one who is, you can say, a legitimate user will receive, or you can say, process the signals. Okay, so let's go through the text and learn more about it. There are two type of hubs, active hub and passive hub. I have already discussed about it. And hubs are the devices used to link several computers. I also have discussed this. They repeat any signal that comes in one port and copy it to the other ports, a process that is called broadcasting. So, for example, if A wants to send information to B, but there are several other computers, then each and every connected lines or all the connected computers will receive the signal, but only B will process the signal or response to the signal, right? So it has limited utility because it has you can say that sharing of bandwidth. Now coming to the next, you can see the diagram how is used to connect multiple computers. You can see we have a port of we have 8 ports, and to these ports our computers are connected, and in these ports generally RJ45 connector is used or inserted to connect the computers. Or you can see the example 16 port, 8 port, and one shared with UP link or uplink, you can say that. And we have other devices, right? Other hubs. We have 64 port as well, right? Now we have our bridges. They join similar topology and are used to divide network segments, right? For example, if you have two LANs with a similar topology, then we can use a bridge to connect these, and they are a little bit smarter and can divide your network into segments. It can filter traffic on the basis of MAC address, so this is a little bit intelligent and can understand your uh, can identify your devices. If it is aware of the destination address, it is able to forward the packets. Otherwise, a bridge will forward the packets to all the segments. They are more intelligent than repeaters, but are unable to move data across multiple networks simultaneously. Unlike repeaters, bridges can filter out the noise, work in data link layer of OSI model, multiple collision domain, but single broadcast domain. The main disadvantages to bridge is that they can't connect dissimilar network type or perform intelligent path selection. For that function, you need a router. Okay, ports are limited to 16 only software specific devices. Okay, now let us move to the switch. This is really very important, and in many times in CBSE, the difference between switch and hub is asked. Now let us. This is actually switches are similar to hubs only. Let us see what are the difference and what are the advantages of hub over the actually switches over the hub. So a network switch is a computer network device that connects network segments, populates MAC address table on the basis of source MAC address of a frame. So basically these switches can identify your machine with the help of a MAC address. So basically when we pass information from A to B, it simply sends information between these two participants only. It do not broadcast to all the channels or to all the clients. So basically multiple or concurrent data communication can be carried out, which is not possible in case of hub. And the third thing is network switches are capable of inspecting data frames, or they are received, determining the source and destination device of that data frame and forwarding it appropriately. Data link layer or layer 2 device, multiple collision domain but single broadcast domain. You don't have to worry about these 2 points. A vital difference between a hub and switch is that all the nodes connected to a hub shares the bandwidth among themselves, while a device connected to a switch port has a full bandwidth all to itself. Okay, so this is really a big difference. And secondly, hub is little bit less costly comparatively to switch. And when we have less than 50 computers, we generally use hub because it is less costly and there is not that difference in transfer rate. But when we our network is larger than 50 computer, then consider using switch. Okay, and basically these can be used interchangeably. Now this is the simple example. Here we have multiple hubs, and these are all these networks are connected with the help of a switch, and switch is also connected to a server. Okay, for example, if 10 nodes are communicating using hub on a 10 Mbps network, then each node may only get a portion of a 10 MB if other nodes on the hub wants to communicate as well. Okay, but with a switch, each node could possibly communicate at the full 100 Mbps speed. So obviously, hub is much more intelligent. Switch is much more intelligent than the hub. Now coming to the router. Router are highly intelligent devices that connect multiple network type and determine the best path for sending data. Routers are normally used to connect one LAN to another. These devices examine incoming packets to determine the destination address of the data. It then examines its internal routing table to choose the best path for the packet through the network and switches them to a proper outgoing ports. So these are important. They know where exactly the client resides in a network. Okay, for example, we have two three network A, network B, and network C. And if you send the information for for a computer which is in network B, then it will simply sends your information to a particular network. So it's really a very intelligent device. However, they are slower than bridges because they are more intelligent devices. As such, they analyze every packet, causing packet forwarding delay. Because of the intelligence, they are more expensive, right? Typically, when a WAN is set up, there will be at least two router used, one in both sides actually. Multiple collision domain, but single multiple domain. You don't have to worry about these things. That's all for today, and have a nice day.